Hi, this is Mouse. Welcome to the Math File channel. In this video, we'll continue with let's say there's the part 3 of the polynomial walkthrough. That is a paper my additional mathematics grade 10 students wrote today. That is the day that this video was posted, not the day you are watching the video, basically. Yeah. And we've gone through question number 1 all the way to question number 7, skipping one question in the process, which we are definitely going to solve again. That is going to be question number 6b, because I told you it's a little bit lengthy. You can pause the video and see if you can solve it by yourself, but I will get into this one in a short time. So just watch the part 1 and part 2 for the solutions to question number 1 and question number 7. Yeah, in this video we're going to solve question number 8. Hopefully we finish up with question number 11, then get time to go back to the question we missed. So let's get into this right away. Question number 8 is a reversed. So this more or less like a reversed way to write a polynomial function. So find the value of x. I think they would definitely ask us. Find the value of x for which f of x is less than 0. So f of x less than 0 is talking about the portion of the graph that is below the x-axis. So I'm looking at this side, less than 0. Oh shit. Yeah, so this side. So we can see that x is in between -3 and +1. So x is in between -3 and +1. Because this doesn't contain equality, let's take off the equality, -1. Then x is going to be greater than, it's +1, x is greater than 5. So x is greater than 5. So that will answer the question. So x is between -3 and +1, and x is greater than 5. Find an expression for f of x. So f of x is going to be equal to a constant. Then we deal with the x-intercept. So there's x minus 3, it becomes x plus 3. That's simple. This was x equal to 1, so this becomes x minus 1, and the other one was at 5, so this becomes x minus 5. So this is the x-intercept. We now consider the y-intercept. So for y-intercept, x equals to 0, so this gives you k 0 plus 3, then 0 minus 1, then 0 minus 5. This is going to be equal to the y-intercept was -5, so let me put it at -5. So this gives you k into 3 times -1 times -5 equals -5, and this should give you a +15. -5 times -1 is a +5, times 3 is +15, so 15k is equals -5. Divide both sides by 15, divide both sides by 15. Then in this case, k should be equal to -1/3. Therefore, my function f of x is going to be, let me write it here, f of x is going to be equal to -1/3, then x plus 3 in one bracket, x minus 1 in another bracket, and x minus 5 in the last bracket. Yeah, a lot of people, I don't know, but I have a feeling that some people write this to be plus or minus. This would be wrong, since this is not a modulus cubic curve. There's a normal cubic curve, and it's a negative cubic curve. That explains the negative over here. So this question is pretty easy. Let's move on to the next question. So question number 9, polynomial p of x equals to 10x cubed plus ax squared minus 10x plus b, where a and b are integers, is divisible by 2x plus 1. When p of x is divided by x plus 1, the remainder is -24. So let's take our time to work this one out. The first thing I notice over here is a factor statement. So the factor statement says that 2x plus 1 is divisible by, the polynomial is divisible by 2x plus 1. So I first equate 2x plus 1 to 0, and I solve for x, where x is going to be -1/2. So this gives you p of -1/2 should be equal to 0, since this is a factor. Then the next statement I see would be the remainder statement. X plus 1 gives a remainder of -24. So again, I equate x plus 1 to 0, then I solve for x equals negative 1. So the statement for that one would be p of negative 1 is equals to negative 24. Let's expand this one. This will give you 10 brackets open negative 1 over 2 cubed plus a brackets open negative 1 over 2 squared minus 10 brackets open negative 1 over 2 plus b is equal to 0. So let's type this on the calculator. So 10, then negative 0.5 cubed. So this gives you negative 5 over 4. So negative 5 over 4 plus this is 1 over 4a. Then this would be a positive 5. You can cross check and see. Plus b equals to 0. So multiply everything by 4. That will give you negative 5 plus a plus 20 plus 4b equals to 0. So a plus 4b should give you a negative 15. So that is equation 1. That is if everything over there is correct, of course. Equation 2, p of negative 1 is equal to negative 24. So this will give you 10 negative 1 cubed plus a of negative 1 squared minus 10 of negative 1 plus b is equal to negative 24. So this will give you a negative 10 plus a minus this plus 10 plus b equals to negative 24. So a plus b equals to negative 24. That's equation 2. Let's use the calculator to solve the simultaneous equation. So there's simultaneous equation, 2 unknowns. So we've got 1, 4, negative 15, and 1, 1, negative 24. So we've got the first one to be a to be 27 and b to be 3. So a is equal to 27 and b to be equal to, is it negative 3? Both of them work. A is negative 27 and b is positive 3. Okay, so let's write a polynomial wall. Our polynomial p of x will then be equal to,
hi guys, this is mouse from math file.
Sorry about that. So p of x is equal to let's go up 10x cubed. So 10x cubed plus a, but a is negative 27, negative 27 x squared minus 10x plus 3. Okay, so we're going to continue from here. Find an expression for p of x as a product of 3 linear factors. So we've done this over and over again. We're going to repeat the same thing. So we've got 10x cubed minus 27x squared minus 10x plus 3. Then we were told that this is divisible by 2x plus 1. So let's do the long division, 2x plus 1. So we've got 10x cubed divided by 2x. This should give you 5x squared. So 5x squared should be on top over here. This 5x squared multiplies everything over here, giving you 10x cubed. I would advise you use the synthetic method I taught in the previous video because I didn't teach into details. I'll create a video for the synthetic explaining all the situations that you can actually use the synthetic method. If you do the subtraction, negative 27, so let me go, negative 27 minus 5 should give you a negative 32. So there's negative 32 x squared. Then I drop the negative 10x and I repeat the process again. So negative 32 x squared divided by 2x. 32 divided by 2 is 16, so there's negative 16x. So negative 16x on top. Multiply that and I get negative 32x squared. Then you do that with the 1, that is negative 16x. We do the subtraction, and this will give you a positive 6x plus 3. So 6x divided by 2x will give you 3. So the 3 would go to the top, and this will give you 6x plus 3, and this goes to 0. Therefore, we can write p of x as a product of a quadratic factor and a linear factor. So p of x is going to be equal to 2x plus 1 multiplying 5x squared minus 16x plus 3. You then take your time to factor out the quadratic expression over here. So 2x plus 1. Then I'll use the calculator and go backwards, since we don't really have much time on the clock. So we've got 5, I'm taking from the side, minus 16, then 3. Going backwards, we get x equals 3, then x equals to 1 over 5. So x equals to 3, x equals to 1 over 5. So the other linear factors would be x minus 3, then 5x minus 1. So take your time and factor out this quadratic expression, and that's what you get. Now finally, write down the remainder when p of x is divided by x. So this is the same as saying p of x is divided by x plus 0. So again, we equate this one to 0. We realize that x is equal to 0. So we write out the p of x, and we find p of 0. Assuming I tell you that this, to find the remainder when divided by x plus 1, you'd have said that x plus 1 equals to 0. Then you solve for x. So this was just x. So I can say it's literally x plus 0 is equal to 0, where x is equal to 0. So we're going to substitute 0 into the polynomial function and see the remainder. So there's going to be 10, 0 cubed minus 27, 0 squared plus 10 of 0 of my, minus 10 instead. It doesn't really change anything, but let me change it. So minus 10, then finally plus 3. So p of 0 is going to be equal to 3, and the remainder is 3. Question number 10. The diagram shows the graph of y is equal to modulus of p of x, where p of x is a cubic function. Find two possible expressions for p of x. Okay, so we start off by saying p of x is equal to k, brackets open, x plus 2, x plus 1, then x minus 4. That's for the x-intercept. Now let's consider the y-intercept. So for y-intercept, x equals to 0. So for y-intercept, x equals to 0. So this gives you k, brackets open, 0 plus 2, 0 plus 1, then 0 minus 4. This is going to be equal to 24, since the y-intercept is 24. This simplifies to k multiplying 2 times 1 times negative 4. So this gives you negative 8k is equal to 24. Divide both sides by negative 8, negative 8. K is equal to 24 times 3 is 24 divided by 8 is 3. So that's negative 3. Therefore, my polynomial function is going to be p of x is equal to, but because it's a modulus function, it's going to be positive or negative. That's why we're told to find two possible expressions. So positive or negative, x plus 2, x plus 1, then x minus 4, and that will answer the question for 3 marks. Question number 10. Let's do question number 11. So question number 11 becomes our last question for today. Actually, that's the last question for the entire progressive paper. This is an exercise. I'm not going to solve that of the exercise. I'm just doing the progressive aspect of it. The first 11 questions. So the polynomial p of x is equal to 6x cubed plus ax squared plus bx plus 2, where a and b are integers, has a factor of x minus 2. Given that p of 1 equal to negative 2p of 0, find the value of a and b. Quite an interesting question. First, we can look out for the factor statement over here. So this factor statement is saying x minus 2 is a factor. Just like we've been doing, we equate the factor to 0 and solve for x. So x in this case is 2. So p of 2 is equal to 0. let's develop this factor statement. That will be 6 of 2 cubed plus a of 2 squared plus b of 2 plus 2 equals to 0. So all that I'm doing is to substitute the value of 2 inside the polynomial function over here. So we can use a calculator real quick. 6 times 8. So 6 times 2 cubed. Let me shake off this. So 6, then 2 cubed. That is 8, by the way. Plus 2. That will give you 50. So this gives you 4a plus 2b equal to negative 50. And let's call this one equation 1. Okay, so the next one is to find p of 1 and equate it to negative 2p of 0. So p of 1 in this case will be wherever you see x, you put 1 over there. So there's 6 of 1 cubed plus a of 1 squared plus b of 1 plus 2. This becomes 6 plus a plus b plus 2, and there's 8 plus a plus b. That's p of 1. Let's attempt to find p of 0. P of 0 will be 6 of 0 cubed plus a of 0 squared plus b of 0 plus 2. So p of 0 is going to be equal to 2. And we're going to substitute everything into this nicely. So p of 1, which is equal to this, will be equal to negative 2p of 0. So let's write that one. So p of 1, which was 8 plus a plus b, is equal to negative 2. P of 0 was 2. So this simplifies to a plus b equal to negative 4 minus 8, since this 8 would be transposed to the other side of the equation. So a plus b equals negative 12. So that's equation number 2. So we solve equation 1 and equation 2 simultaneously, and we get the values of a and b. Again, there's simultaneous equation. I know you should be able to solve quadratic simultaneous equation. So normal 2 linear simultaneous equations shouldn't be a problem. So I'm going to use a calculator to solve this instead of solving it manually to save some time. So 4 to negative 50. Then we've got this one to be 1, 1, negative 12. This gives you a to be equal to negative 13 and b to be equal to 1. So a equals negative 13 and b to be equal to 1. Is there more? Okay, there is more. So using the values of a and b, find the remainder when p of x is divided by 2x minus 1. So let me write the p of x well, since we now know what a and b is. So p of x is going to be equal to 6x cubed plus ax squared. So 6x cubed plus ax squared. A is negative 13. Then if we move on, we've got plus bx plus 2, and b is 1, so plus x plus 2. So that's p of x. We can actually check this one if we are correct. So let's check. Since there's a factor, we can check that. So we're told that x minus 2 is a factor, so I can quickly check that one. Or we can also use the synthetic method to check this. Let me use the synthetic method to check. No, let's use the calculator. So 6x cubed minus 13x squared plus x plus 2. So calc negative, was it negative 2? No, it's 2. P of 2, this should give us 0. Yeah, that is correct. It was 2. So x minus 2 equals 0, x equals to 2. So we are correct with this one. So let's take this one, the polynomial function. We're told to find the remainder when 2x minus 1 divides this. So we first equate the 2x minus 1 to 0 and solve for x equals to 1 over 2. So we then find p of 1 over 2, which is going to be 6 of 1 over 2 cubed minus 13 of 1 over 2 squared plus 1 over 2 plus 2. So calc again. 1 over 2. That gives you 0. So it means that 2x minus 1 is also a factor. That's quite interesting. So let me confirm. So yeah, 2x minus 1 is also a factor. So we've gotten 2 factors already. So let's get the third factor. So factorize p of x. We now know that p of x is, the first factor was x minus 2. Where is it? Yeah, x minus 2. And the second factor is now 2x minus 1. And we don't know this, so we can say that this is going to be ax plus b. I'm trying to use a different method rather than using the factorization. So the comparison method will be the last thing I'm going to do today. I think we are so close to our 30 minutes mark, or maybe we've even passed the 30 minutes mark. So let's expand and compare. So expanding, this should give you 2x squared. This time this gives you negative x. This time this gives you negative 4x. This time this gives you a positive 2. All this multiplying ax plus b. This is not compulsory though. You can use the long division, but I feel like I have to use this since I've not used it in any of the questions as we started. Okay, let me cross check this to be sure. So x times 2x will give you 2x squared. X times negative 1 will give you negative x. Negative 2 times 2x will give you negative 4x, and negative 2 times negative 1 will give you a positive 2. Okay, then if you multiply this 2, you get 2ax cubed. Then we've got the next one to be plus 2bx squared. Then the negative 5 multiplies everything, negative 5ax squared. Then negative 5 multiplies this, negative 5bx. Then 2 multiplies this, plus 2ax. This multiplies this, plus 2b. I actually don't like this method because it's too lengthy. So we've got 2ax cubed plus those with the x squared. Let's see if we can gather them. This with x squared, and this also with x squared. So we've got 2b minus 5a with x squared. Then let's try to gather those with the x. So this with x, and this with x as well. So plus negative 5b plus 2a with x, and those without x, we've got only 2b. So we have to compare it with this one, which I don't have space. Okay, so in this case, we can say that 6 is equal to, since I'm comparing 6x cubed to 2ax cubed, so 6 is equal to 2a, where a is going to be equal to 3. Then we can do another comparison. So 2b, this one without x, and the one without x. So 2b, or 2 is equal to 2b, and b is equal to 1. Therefore, the final answer would be p of x. Let me use a different color. So p of x is equal to x minus 2 in one bracket, 2x minus 1 in another bracket. Then a was 3, so 3x plus 1 in this bracket. And that will end the question. So I still couldn't solve this question, the B part. I'll get back to the B in just a single video. That will take about 5 to 6 minutes long. So that will be all for today. Enjoy the rest of your day. And yeah, there's a test given to my grade 10 students. It wasn't that challenging, and yeah, I pray they do so well. Bye bye for now.